Hi, good evening, everyone. We'll go ahead and we'll take statistics question today. So, is my screen visible? Give me a yes or a no. Okay. There was some technical issues today, but anyways, I think it's resolved. Okay. So let's go ahead and let's take question number 6. Try to do this question yourself. I have got a lot of statistics, good stats question. Let's see how much we can cover today. Then we'll try and take one more stats class and we'll wrap up all these questions. Okay, just try question number 6 quickly. Okay. How about others? Suppose we are interested in estimating the mean height of MA students in Delhi University. Average height estimated from random sample of size 30 is better than size of 20. It is only asking why sample size of 30 is better than sample size of 20. It's asking why sample size of 30 is better than sample size of 20. What has it got to do with central limit theorem? No, it is not asking when central limit theorem applies or what central limit theorem says. It's only asking why sample size of 30 is better than sample size of 20. 30 is better because when we increase the sample size, our precision increases. When we increase the sample size, our error decreases, right? So that is it. That is it. This is what the answer should be, that my precision increases as I go ahead and as I increase my sample size. It has got nothing to do with what central limit theorem is saying, right? So the correct answer to this question is simply B. It is not C. It is not D also, right? We are not going ahead and talking about size being small related to biasness. I can still get an unbiased estimator, isn't it? My still expected value of the sample, it can be equal to the value of the parameter, right? We are not talking about being biased or non-biased. We are just saying that, okay, as you increase the sample size, the precision increases. Precision increases means the amount of error that you commit should decrease. That means your variance should decrease. That means your standard errors should decrease. That's it. That's the only advantage of going ahead and of having a bigger sample size. 30 will be preferred over 20, 40 will be preferred over 30, and so on and so forth. That's the only thing we have. उसके अलावा और कोई रीजन ही नहीं है बड़े सैंपल को होने का. बायस्ड अनबायस्ड कोई रीजन नहीं है. छोटे सैंपल में भी मैं अनबायस्डनेस लेके आ सकती हूँ, right? So the only thing which is correct here, that is going to be that the answer will be B. Answer will be B, right? Okay, do question number 7 now. Remember, central limit theorem is only saying when distributions become normally distributed. Please remember this. It prescribes for normal distribution to hold, not for better estimate. Better estimate होने के लिए sample size 30 है, ये central limit theorem नहीं बोलता है. Okay, question number 7. A doctor testing a diagnostic tool for rare disease wants to minimize the chance that will test a patient to be healthy when she is in fact sick. Healthy when she is in fact sick. Okay, so we want to find out the probability of being healthy given it is false. probability of being healthy given it is false, right? And when she is in fact sick, null hypothesis is patient is healthy. Null is patient is healthy and patient is in fact sick. That means null is false. So it means that I want to find the probability that I accept null, that she is healthy, but null is false. But null is false. Patient is not healthy. Patient is sick. Null is false. So what type of error would this be? Definitely it is a type 2 error. Isn't it? Definitely it is a type 2 error. And type 2 error is what? What is it called? False negative. फॉल्स नेगेटिव क्यों है? क्योंकि हम बोल रहे हैं कि वो हेल्दी है बट वो एक्चुअली फॉल्स है. इट्स अ फॉल्स नेगेटिव स्टेटमेंट, राइट? सो आंसर विल बी डी. आंसर वुड बी डी. ओके, नॉट बी. इट विल बी डी. यू हैव टू थिंक. फॉल्स पॉजिटिव नहीं है. नल, अगर नल हाइपोथेसिस होता कि पेशेंट इज सिक, then I could have thought in that direction. Null is patient is healthy. And I'm falsifying that statement. I'm giving a negative statement that she's, so we, null is patient is healthy, right? And I am going ahead and saying that it is false. And I'm still accepting it. So I am doing a false negative around it. So answer will be D. It's a false negative statement. And anyways, type 2 error is called false negative. Right? Okay, go ahead. Try the next question. Acha, what about type 1 error? Anyone who can tell me what will be type 1 error in this case? When he rejects null, which is true, isn't it? So what statement can you pass there? Yes, that's true. It will be false positive. That is correct. Yes. So type 1 error is always called false positive. Make this table quickly. True, false, rejected, and not rejected. Okay. Type 1 error, type 2 error. Probability is represented by alpha. Probability is represented by beta. This is called false positive. This is called false negative. False positive and false negative. ठीक है? So यहाँ पे हम लिख रहे हैं. Here I can write null hypothesis. Remember this table, beta. Null hypothesis true, rejected. This one. Type 1 error called false positive. Null hypothesis false, not rejected. Type 2 error. It's called false negative. Okay. This is true positive. This is true negative. This is 1 minus beta, 1 minus alpha. Okay. Yes, that's correct. Anything which is not clear here? Okay. Let's go on to the next question. So the next question that we would be picking is this. Question number 8. Give this a try. Suppose you have the following estimated regression. I'm also taking this question related to econometrics. So ln y is equal to 1.2 plus 0.5 x. Which of the following is good interpretation estimated property between x and y? Give it a try. Only this simple kind of questions can be asked from regression. बहुत difficult कुछ नहीं आएगा unless it's a gate paper जिसमें they can ask you about probit logic because it came last time. Very good. What about others? So ln y is given to me as 1.2 plus 0.5x. Differentiate both sides. 1 by y dy is equal to 0.5 dx. So dy by dx, this will be y भी है यहाँ पे, will be 0.5. ठीक है, अब देखो what this says, पहले एक basic understanding लाओ. What this equation says is that there is relative change in y upon absolute change in x, and that is 0.5. Relative change in y upon absolute change in x is 0.5. माने जब हम y x में 1 यूनिट से चेंज करते हैं तो y में relative change आता है. अब relative को क्या करते हैं ना, we can convert this in terms of percentage. तो ये dy by y है. If I multiply this with 100, so this will be in terms of percentage. So I can multiply both side by 100. और ये relative change की जगह पे I can use the word percentage change in y. So it will be 50. So what we are saying? Percentage change in y due to unit change in x. Percentage change in y due to unit change in x will be 50. So yes, answer will be A. Percentage change in y due to unit change in x. Okay, take the next question. Do question number 9. Give it a try. These are all one marker kind of questions that you can expect in exam. So you don't have to spend a lot of time on it. बहुत जल्दी जल्दी quickly हमें करने हैं questions. I will show you what 2 marker question looks like. Okay, let's see. A1, A2, A3 be the independent event with probability P1, P2, P3. Probability that none of these events occur. So probability A1 not occurring, मतलब A1 dash intersection, A2 not occurring, A2 dash, A3 भी नहीं हो रहा, A3 dash. None of the events are occurring. But these are independent events. तो इसके intersection को we can write as multiplication. और ये क्योंकि complement है, I can open this up. है कि नहीं? And A1, A2, A3 का क्या probability दिया हुआ है? P1, P2, P3. Okay. Isn't it? So you can go ahead and you can simply get the answer as C. That is correct. Okay, let's go on to the next question. So the next question that I have marked number is, okay. This is a 2 marker question now. This can come as a 2 marks question. So think and do accordingly. Take this one, give it a try.